everybody, Mr. Rubo here, and today we're going to continue with our modeling, but we're actually going to talk about something that is going to come back around, but we want to introduce it here first because it's something that we can do at this point. It ties in very nicely with the modeling, but it's a way when we use our models. We want fairly accurate models to be used because you don't want to have something that's not accurate, right? It wouldn't be helpful. So a good way of telling how accurate a model is using something called residuals. So this will tell us the difference between the actual data value and the predicted value we get from our equation. So you can kind of see here, residuals, you take the actual, you subtract the predicted. Kind of shorthand here, it's y minus y hat. And yes, that little symbol we say y hat. So the way this works is we need to put in this data, get in a regression model, which we did this in the last video. This is example 1. So it's the same data, same x's, same y's. And what we're going to do here is we're going to figure out our actual value, our predicted value, our residual, and then what it means. And then I'm also going to show you how our calculator can do residuals really quick. Okay. So nice thing here. So if you read this, you go through what is the residual of the baby at 5 weeks. So that means I'm looking here. So my actual value is just the 4.4. No issue there. We just get that value right from the data. That's the actual value. Our predicted value is that what we get when we substitute into our equation, which if you recall from the last video or from just earlier in the notes, you get this equation right here when we do the regression, 3.545 plus 0.185, and we want week 5, so we're going to go ahead and substitute in. That is a 5. Switch those two around. There we go. 0.185 parentheses 5. And you're going to just type that all right in the calculator. I've already done it, so I'm not going to switch back and forth. But we get 4.47. Sorry, that's a 7. I did it, but I can't read my own handwriting. So y equals 4.47 is what we would call our predicted value. So we can go ahead and do our residual equation right here. So we take the actual minus the predicted, and we get a negative. Let's see. There we go. Negative 0.07. Again, you could use a calculator in that case to get this. And you will get residuals that are positive and negative. And hopefully, and if you get where it's all positive or all negative residuals, then your model isn't a great model. But when we look at this, a negative residual, if we think about this, the actual value is 4.4. The predicted value was a 4.47. So if we just kind of think about this, well, the predicted value was higher than the actual value. That means for this one, we have a overestimation, which is always the case when you have a negative residual. Okay, so that's what our interpretation here is. The model overestimated the actual value. Okay, this is always probably the most confusing part. Is a negative residual means you overestimated, and oh, that's really bad. Overestimated, where a positive residual means you underestimated. Okay, now let's real quick just go to our calculator, because our calculator has a nice feature to it. So you can see I have this data already in, and if you recall, the way I get there is stat, then edit. And then as far as our calculator, it'll actually predict all of these residuals. So in case I wanted all of them, which again, when we get to 2.6, we'll really dig deep in these residuals. The way we can do this is you move over to L3. So we're going to the third list, and you go up. So it's highlighting on the L3, and then you hit second stat. And you'll see all these options, L1, L2, all the way to L6. And then the seventh one is resid, which is residuals. And you hit enter, you'll see it says L3 equals L resid. You hit enter, and there we go. It just popped all of them there. And you can actually see, hey, 5 was a negative 0.07. And again, we'll touch a little bit more on this later. But one of the things with residuals is if you wanted to plot them, which is a residual plot is something, is going to give us a lot more information. The way our calculator can do it is you go second y equals, you'll come to this this screen that says stat plots, choose the first one, we'll turn it on, and then because we want the residual graph, we'll leave L1 alone, but L2 we're going to switch to L3, and the way we do that is to second 3, how it says L3 above that 3. So now we have L1, L3, and I'm going to hit zoom 9. And this right here is our residual plot. So the 5 data values, how far away the actual and the predicted values were. With the residual plot, you want actually no pattern, and you want positive and negative values. Because right, if they were all positive, then your model would always underestimate. If you had all negative, then your model would always overestimate. So you want kind of a mixture of both. That is a good model, but you also want no pattern to the residuals. If there's a pattern, then your model's not good. Again, we'll touch on this in 2.6, but I did just want to kind of touch on it now, so you're kind of have a head start. All right. Well, thanks for watching, and have a good day.